Okay, section 10.4 covers adding and subtracting radicals. So we reviewed how to simplify, we reviewed multiplication and division. Now we're going to do adding and subtracting. All right, let's start by thinking about 2x squared plus 5x squared. If we have these two things, we call them like terms because they both have x squared. And then we just add the whole numbers. So 2 plus 5 is 7. Radicals work the same way. As long as the radicals have the same number inside and the same index, we would just combine the like terms on the outside. So 3 plus 5 is 8. Keep the radical the same. This first one, they both have radical 11, so we would just add 10 plus 4, leave the 11. Here they both have cubed root 6. If there's nothing in front, it's 1, so 5 plus 1 is 6. This one right here, the 4 doesn't have a radical, so we can't combine it. That's as far as it can go. And these are not the same, so we can't combine them, so that's as far as we can go. Sometimes when you first look at a problem, you think, oh, those aren't the same. But if we simplify the radicals first, then we'll be able to combine them. So 45 is the same as saying 9 times 5. The square root of 9 is 3. We have a root 5 left. 20 is like saying 4 times 5. The square root of 4 is 2, and we have a 5 left on the inside. Now our radicals match, so we can combine 3 plus 2 is 5. Subtraction works the same way. First, we're going to reduce. 27 is 9 times 3, which would give us 3 radical 3. Bring down the root 5, and then that's as far as I can get. You do want to simplify, but then once they're still not the same, we stop there. Try these other 4 as you're ready. Check them, figure it out, watch a couple more. It's up to you, but see how you do. All right, so 54 is 27 times 2. So 27, the cubed root of 27 is 3. Leave the 2 inside. And 4 times 3 is 12. Bring down the minus sign. I don't know why I did it in this order. Cubed root of 16 is 8 times 2. Cubed root of 8 is 2. 5 times 2 is 10. Now our radicals match. 10 cubed root 2 minus 12 cubed root 2. And 10 minus 12 is negative 2. Here, if I reduce the 12, it's 4 times 3. Square root of 4 is 2. The root 3 here is already simplified, but now they match and I can add. 2 plus 7 is 9. Here, we're going to do cubed root 16, so that's 8 times 2, which becomes 2 cubed root 2 plus cubed root 2. So if we have 2, add 1 more, we get 3. All right, over here, the 3 root 2 is already as simple as it can be. 8 is 4 times 2. Square root of 4 is 2. Now that's as far as it can go, so we bring it down. 18 is 9 times 2. Cubed root of 9 is 3. And that's as far as we can go, so we bring it down. Now we combine like terms. 3 plus 2 is 5, plus 3 is 8, so we get 8 root 2. All right, let's keep going. 4th root. So if I look under my 4th root on that chart from before, 32 is 16 times 2. The 4th root of 16 is 2. Leave the other one inside. This is already as small as it can get. Now we have like radicals, so 3 plus 2 is 5. Don't drop your index here. That's the biggest thing people will do wrong is all of a sudden they forget to write that and combine things they shouldn't. All right, to break this down, the square root of 4 is 2, but I'm going to leave the x inside. Negative 2 times 2 is 4. Bring down this x, and that works the same way. We're saying negative 4 plus 1. That gives us negative 3 root x. So nothing changes just because there's letters there. Let's try another one. 3 to 3k. We can't break that down at all. Next one, 12 is 4 times 3. And we still need the k. Square root of 4 is 2. Leave the 3k inside. 5 times 2 is 10. All right. Now we're going to do this. 48 is 16 times 3. And then the square root of 16 is 4. And 9 times 4 is 36. Now all our radicals match. So 3 plus 10 is 13. Plus 36 is 49. All right, here's a couple more. Subtracting, same exact thing. We're just going to subtract like terms. 5 minus 3 is 2. And we've got that. Here, we can do 8 minus 3 is 5. This last one has an 11, so we can't combine that. So this is going to make cubed root 5. And then we just carry the cubed root, carry the cubed root 11 down. All right, this last one here. We can't combine this because it's a cubed root where the other ones are squared. So I'm going to do 5 minus 2 is 3. And then just leave that cubed root z separate. And that's as far as we can go. All right, try a couple more. If we look at these, we have an xy squared. Can't be simplified because of the 3, but these are the same, so we're just going to subtract. 3 minus 2 is 1. And we can write it with the 1 or without, it doesn't matter. Next problem, square root of 16 is 4. Leave the x cubed inside for now. Remember, x cubed is like saying x squared times 1, or times x. So we can actually take the square root of x squared is x, leave the other x inside, and then same thing right here. Square root of x squared is x, leave the other x inside. And 4x minus 1x is 3x with the square root inside. So there's one way to do that. All right, let's look at that one. Before we can do anything, we need to get the bottom. So this one right here is going to become cubed root of 5x over cubed root of 27. And the cubed root of 27 is 3. And then over here we have cubed root of 5x over 6. So before we can subtract, we need a common denominator. So we have to multiply this by 2 over 2. And we get 2. I forgot that was a cubed there. So we get 2 cubed root 5x over 6 minus cubed root of 5x over 6. And 2 minus 1 is 1. So we get cubed root of 5x over 6. And that's as simple as we can get that one. All right, got a couple more here. Before we can subtract, we need a common denominator. So I'm going to multiply this one by 4. I'm going to multiply this one by 3. 4 times 5 is 20. 4 times 3 is 12. 3 times 2 is 6. 3 times 4 is 12. And then 20 minus 6 is 14. Root 2. And 14 and 2 are both divisible by 2. So we get 7 root 2 over 6 is our lowest term. So we always want to simplify as far as we can. All right, let's try this big one. Well, the fourth root of 81 using that chart is 3. A to the 5th, if we take out 4, we bring 1 out and leave 1 inside. And with the b, if we take out 4, we bring 1 out and leave 2 inside. Really, we're subtracting because it's like saying, hey, I'm taking out these 4. That's why I'm only bringing out the 1. Then if we do the same thing over here, the fourth root of 16 is 2. We can't take out the a because the exponent's less than 4. We can't take out the b because the exponent's less than 4. So we leave that in there. Now our radicals match, but we can't combine the 3ab and the 2 because those aren't like terms. So we could stop here. And then My Math Lab might have you factor out that greatest common factor, which is the radical. And then you're left with 3ab minus 2. So it's like dividing that out versus distributing. I would take either of these on the test. My Math Lab, I think, makes you go the one more step. All right, and then the last one of these. So cubed root of n to the 5th over cubed root of 27 minus 2 cubed root of n squared. So n cubed root of n to the 5th. Well, if I take out 3, because we need that 3, puts an n on the outside. And then 5 minus 3 is 2, so we leave that on the inside. Cubed root of 27 is 3. Then if we have a 3 on the top or the bottom, that goes away. So I'm left with n square root n squared. I did that. Or cubed root, sorry, n squared. Minus 2 cubed root n squared. So same thing, that's okay. But if you need to keep going, you're just going to take out that common factor and rewrite it like this with the n minus 2. All right, so that helps us with that's multiplying. Now let's look into, first we're going to multiply binomials. So we FOIL these. Square root times the square root is going to cancel that out, so we're left with a b. 5 times square root b is 5 root b. 4 times square root b is 4 root b, but it's negative. And the negative 4 times 5 is negative 20. Now we combine the like terms, so we get 5 minus 4 is 1. So we get this. So when you're foiling with radicals, you're still going to get 3 terms. You're still probably going to end up with a radical. You just do what you need to do. To cancel the radical, we're going to look at this one. 4 times 4 is 16. 4 times root 3 is negative 4 root 3. 4 times positive root 3 is positive 4 root 3. And root 3 times negative root 3 would be negative 9 because the roots cancel and when we have that negative sign left. Now we combine like terms. 16, that shouldn't be a 9. Sorry, that should be a 3 because it cancels the radical. And then 16 minus 3 is 13 and the radicals cancel. If you look at this, they're the same thing except the second number has become negative. These are what we call conjugates. In order to get a conjugate, we change the sign of the second number. So this would become 1 minus root 2. Then if we FOILed those, the radical would cancel. This would become 5 plus root 3. If we FOILed those, the radical would cancel. All right, rationalize the denominator. When you see this, square roots are irrational numbers. They go on forever. So we want to not have them on the bottom of a fraction. So in order to rationalize the denominator, we're going to get rid of that radical. We're going to multiply, but by whatever the radical is on the bottom. So that says root 3, so we're going to do root 3 over root 3. Multiply across. 1 times root 3 is root 3. And then root 3 times root 3 is the square root of 9, which is 3. So in a sense, we're just canceling out that radical. So here we would do the same thing. 1 times root 2 is root 2. And then those two radicals are going to cancel and we get root 2 over 2. We do the same thing if there's other numbers on the bottom. We're only worried about the radical. So 3 times root 3 is 3 root 3. And then the bottom, we have the 5. Root 3 times root 3 is 3. And then those, we have a 3 on the top and the bottom, so we can cancel. If we didn't have a 3 on the top, we would have just multiplied the bottom. Same thing here. We're going to make it root x over root 24. Then, to make my life easier, I'm going to simplify first. There's 2 ways. One way is to simplify first. So I'm going to say 24 is 4 times 6, which is 2 times root 6. Now if I take this, I can multiply by root 6 over root 6. And on the top, I get root 6x. And on the bottom, I get 2 times 6, which is 12. That's one way. The other way is to just straight multiply by root 24. On the top, we would get 24x. On the bottom, we'd get 24. Then we simplify the top. So that's 4 times 6 times x, which gives us 2 root 6 over x. And 2 over 24 reduces to 1 over 12. So it doesn't matter if you reduce first or last, you'll get the same answer. All right, so this one's a little bit different because we have a square root and an exponent. So again, we can do the same thing. We can do xy, and we can reduce this first, where we take out the 2 and leave that. Then those simplify, and we're left with x over root y. Our other option is not to simplify first, but to just multiply by cubed root of y cubed, which would give us xy square root of y cubed over y cubed. Then we would reduce, so this would end up being xy times y root y over y cubed. If I take 2 of these out, there's 1 left down here. So I get root y over y, because here I didn't finish. I forgot to get rid of the square root. So again, doesn't matter what order, depending on what order you do it in, just make sure here you wouldn't have gotten full credit because there's still a radical. All right, now we're gonna go back to those conjugates. When you divide, if you just have the radical on the bottom, it's easy. All right, so when we have a square root on the bottom, but it has a plus or a minus, then we have to use the conjugate to get rid of that. So instead of 1 plus root 2, I'm going to multiply by 1 minus root 2. To do this, I'm going to distribute the 1, which in this case doesn't change anything. And on the bottom, we're going to FOIL. 1 times 1 is 1. Then we have negative root 2, positive root 2, and that becomes negative 2. If we combine like terms on the top, we can't. And if we combine like terms on the bottom, those are going to cancel, so we get negative 1. And then dividing by negative 1 just changes the sign, so there's our answer. Same thing here. Instead of 2 minus root 5, we're going to do 2 plus root 5. So here we do 3 times 2 is 6. 3 times root 5 is 3 root 5. Root 5 times 2 is 2 root 5. And root 5 times root 5 is 5. Repeat on the bottom. We have 4. We have positive 2 root 5, negative 2 root 5, and then negative 5. Now we're going to combine like terms. So on the top, we have 6 plus 5 is 11. And 3 plus 2 is 5 root 5. On the bottom, we have 4 minus 5 is negative 1. And again, this is just going to change the sign to negative 11 minus 5 root 5. All right. Same thing here. We're going to multiply by the conjugate. So root x plus 2. It doesn't matter which one you change as long as you change one of them. Distribute. Root x times root x is x. Root x times 2 is 2 root x. Root x times root x is x. Then we have positive 2 root x, negative 2 root x, negative 4. So on the top, we have x plus 2 root x. And on the bottom, we have x minus 4. And that's as simplified as we can get it. All right, the last question is, when it's a cubed root instead of a squared root, we can't just multiply by the cubed root because they don't cancel out the same. If I were to rewrite this as a fraction, it would be x to the 1/3. In order to get rid of the radical, we need those exponents to add up to 1. So we're going to multiply by x to the 2/3, because 1/3 plus 2/3 is 3/3. So here, if I multiply straight across, we get 5x to the 2/3. And then here, 1/3 plus 2/3 is 3/3, which is the same as x to the 1. So you could leave it like that. If it calls for radical form, then we just have to put the x back into a radical. So either of those two is correct. So that is the end of 10.4. Let me know if you have any questions.